Hey, I'm Aryan, and I've developed a tool that helps analyze microscope images of additively manufactured samples. And in this video, I'm going to demo it to you. So before we even start, as you can see, this code has a GUI, which makes it very easy for different labs or new labs to use this code right away with very little training. And I think that's a very important feature for a general tool. So this is the upload screen of this tool, and you get started by simply uploading the images that you want from your file explorer. So something very cool about this code is that you can actually process the images in batches rather than doing it one by one, as we currently do in our lab. And from my conversations with people in industry, it's often done one by one in industry as well. So this is quite automated and could save a lot of time being able to do the processing in batches. Then after you upload the images, you progress on onto what I call the foundational steps of for finding the scale bar and finding the substrate. So the way you find the scale bar is just by tracing out a box around the scale bar, and it will automatically pick up the line and pick up the text in most cases. And what you can do is then apply the scale to all images if all images happen to have, the same scale. Then you move on to the substrate removal screen, and here you can click auto detect the substrate in all images, and it will auto detect a line for the substrate. It doesn't yet auto detect the endpoints of the substrate or the endpoints of the interface. That's something you still have to do a bit manually, but I'm working on a tool that can automate this part as well. So once you've completed these foundational steps, you I'm not done. My fault. Sorry. Okay. Oh yeah, and if for whatever reason the auto detect substrate doesn't work for you, there's always manual point selection that you can do. There you go. Yeah. And I'll just show you quickly how manual point selection works. You basically select how many ever points you want, and that will be a substrate line. For now, I'm going to disable manual point selection and auto detect the substrate because it was working. Also, if you happen to have wire EDM'd your sample before wire EDM'd your additively manufactured part of the substrate, you can also auto detect an EDM cut. I can demonstrate that in another video. So once you're done with these foundational steps, you can move on to the analysis menu screen. Now, in the analysis menu screen, there are some basic tools that I have developed, like porosity analysis, thickness versus height, and notch detection, which I'll show you. But here lies also the what I think is the coolest and most powerful part of this code, which is the custom script screen. But I'll show you that later. First, let's look at some of the uh, built-in analysis tools that I've developed. Um, so in the porosity screen, there are a lot of options as you can see. First of all, if you don't like the number of pores that this is picking up, you can play around with the contrast until it picks up all the pores. Um, Once you're done with that, you can also change the height to which it measures the porosity. So uh, I will just set that to 3 mm for now. And oh, this height is also the height of the substrate, by the way. You can filter the pores by the area. You can also filter the pores by how spherical they are. So if you want to isolate, for example, gas porosity from lack of fusion porosity, you can get the distributions for sphericity and for size distribution. And finally, you can also measure porosity at intervals, and you can see all the data as being output in this table over here. And the application for this would probably be if you want to kind of get it layer by layer, the porosity. Um, This is the thickness versus height tool. This is a very useful feature that used to take us at least 30 minutes an image to do in the lab, but here you can, as you can see, easily get thickness versus height, and you can even export it as a CSV. So this helps you with the geometry of the AM sample. And you can also calculate how much excess material was deposited, as you can see here. If, for example, you want to mill this down, you can know, okay, that 67% of the material is being used if you want to mill it down to a standard shape, and the remaining, 23, 33% gets thrown away. So those are some of the uh, tools that I developed out of the box. But now I'm going to show you the coolest part of this code, the custom screen, which will allow us to build a whole community and a whole suite of third-party open source codes that can be plugged into this and can leverage the GUI and the um, metadata, the foundational data that we collected in the previous steps to make more complex analysis. So the custom code is written with a library that I developed, and I'm going to show you that the specification for that library here. Um, the library makes it very easy to add GUI features to your tool, and B, it makes it very easy to access the metadata that we got in the previous steps. By metadata, I mean the foundational data, the scale bar size and the substrate location. So here's how easy it is to add a add a GUI feature to your code. You just have self.add and then one of these GUI input features. To get the metadata, it's as easy as getting something from this dictionary called metadata. Yeah. So that's how easy, and you just need to write one function that has an output image, which will be the image that comes on here, and an output uh, dictionary, which is the results that you can export as a CSV. And for debugging, you even have a debug console over here, so whatever you print comes here. And yeah, that's what I think is the most powerful feature of this code. You can also get an LLM prompt. If you click on this, it'll download a text file, which can be used as an LLM prompt if you want to develop the code automatically. And I'll actually show you right now one code that I developed using that method. It's this one over here, and it basically just finds the midpoint between the two interface endpoints, right? It's very simple, but it's also uh, has a GUI and everything. As you can see, it has a lot of GUI features. If you can change the color, you can change the height of the line, and you can change the thickness of the line. And that's obviously a lot of GUI features. But if I show you how easy it was to write this code, it was only 78 lines, and this is how easy it was to make the GUI. So yeah, that's my code. I think it's very powerful and it can be very useful at AMPF. I'd love to hear your feedback. And if you work in a field outside of AM, I'd really like to hear your feedback to see how I can make this tool even more general. Thank you.